Section 1.4, Definitions of Trig Functions. Please complete the warm-up and refer to the discussion board if you have any questions. From our previous sections and our previous assignments, we have done homework problems and samples in class that have talked and we've discussed about sine and cosecant being reciprocals, cosine theta and secant theta being reciprocals, and tangent theta and cotangent theta being reciprocals. This just shows and illustrates a diagram that sine and cosecant are reciprocals and displays that by 1 over cosecant theta for sine, and for cosecant theta, 1 over sine theta. And it's similar for both cosine and secant and tangent and cotangent. In our first example, they want us to find each function value if given the following. Our first one is, if we are given secant theta is equal to 2/3, they want us to find cosine theta. Well, let's take a look back at our previous diagram. We know on our other diagram, we have cosine theta equal to 1 over secant theta. We know what secant theta is. We're finding cosine theta, so that's the one we want to use. Let's go back to the example, and we're going to follow that procedure and use that equation. So cosine theta is equal to 1 over secant theta. And then we just substitute in and simplify. Cosine theta is equal to 1 over 2/3. Cosine theta is equal to 1 divided by 2/3. Cosine theta is equal to 1 times 3 over 2. And cosine theta is equal to 3 over 2. Our second example, we need to find sine theta if cosecant theta is equal to a negative 15 square root of 3. Well, let's go back to our previous diagram. We're finding sine knowing cosecant. In our previous example, it shows us in a square box here that sine theta is equal to 1 over cosecant theta. I'm trying to find sine. I know cosecant, so the one in the box is the one I'm going to use to find the solution to the next problem. So here, I know that sine theta is equal to 1 over cosecant theta. I follow the same procedure I did on our previous problem. So here, sine theta is going to equal 1 over the negative square root of 15 over 3. Sine theta will equal 1 divided by the negative square root of 15 over 3. Sine theta will equal 1 times, find the reciprocal, a negative 3 over the square root of 15. So sine theta is equal to a negative 3 over the square root of 15. But in this fraction, I have a radical in the denominator, which is not acceptable. So I have to rationalize, which means I'm going to multiply the top and bottom of my fraction by the denominator, which is the square root of 15. I simplify, so sine theta is equal to a negative 3 square roots of 15 over the square root of 15 times the square root of 15, which is the square root of 225. But the square root of 225 is 15. And then one final simplification, and I get the negative square root of 15, and a negative 3 over 15 is a 5 on the denominator. So my final solution is square root of 15 over 5. Our next slide shows a diagram of the signs of function values inside of specific quadrants. Here I have my 6 trig functions and the value being positive or negative associated with them determined by what quadrant we are located in. What we need to do is see, well, how is this chart generated? So let's look at an example. Let's look at an angle in a coordinate plane. In this coordinate plane, I have an initial side on the x-axis, and I have a terminal side in the first quadrant. And let's put a point on that terminal side. When I do that, I can create a triangle that generates my x value and my y value. And my point also has an x value and a y value associated with it. And in this case, since I'm in the first quadrant, my x value is positive and my y value is positive. Let's recall that my r value is the distance from the origin to the point on the terminal side. And we know when I'm finding the distance or the length, that's going to generate a positive value. So in this situation, my x is positive, my y is positive, and in all situations, my r will always be a positive number since it is a length or a distance from the origin to a point on a terminal side of an angle. With that in mind, let's go back to the diagram before. In this diagram, I have sine theta given to me right here. And what we do know is that sine is defined as the y over the r. And in quadrant 1, we know that the y value is positive and the r value is positive. Therefore, positive divided by a positive, in quadrant 1, you can see illustrated in my diagram that sine theta is positive. Let's proceed by taking a look at some other quadrants for sine. If we go to the second quadrant, and we have a triangle formed there, I'm going to be given a point on that terminal side. And in this instance, I'm going to have an x value and a y value associated with that. Here, I will have a point that will have a negative x value and a positive y value. If I refer back to the diagram, I can see that my sine is still y over r, but in quadrant 2, I'm given a positive y over still a positive r. So the value of sine in quadrant 2 is still positive. Continuing in the problem, I can put an angle in quadrant 3. In this situation, I can form a triangle that has an x value and a y value, and associated point on the terminal side with an x value that is still negative, and a y value now, since I'm in quadrant 3, is also negative. Referring back to the diagram, in quadrant 3, I'm still y over r since it's sine theta. I have given a negative y over a positive r. Negative divided by a positive gives me a sine theta that will be negative in quadrant 3. Let's finish the illustration by making an angle in quadrant 4. In quadrant 4, I'll form a triangle, and on the terminal side of that angle, I'll put a point x and y, and in quadrant 4, my x value is going to be positive, and my y value is going to be negative. If I refer back to the diagram, my sine theta in quadrant 4 is going to have a y value that is negative and an r value which is positive. And in this situation, negative divided by positive is going to give me a negative value for any sine theta in quadrant 4. It follows that I can complete this diagram for the remaining trig functions the same way I did sine theta. For example, I know that cosine theta is equal to x over r. And all I need to do is go through my quadrants and determine where x is negative and positive, knowing that r is always positive. That generates the columns shown here for quadrant 1, 2, 3, and 4. I'll put the previous diagram under our group resources on our group page. Let's take a look at another example. We want to identify a quadrant given some specific constraints. Our first example asks us to identify the quadrant or quadrants of any angle theta that satisfies tangent theta greater than 0 and cotangent theta greater than 0. Let's recall that tangent theta is equal to y over x, and cotangent theta is equal to x over y. Now, let's identify what quadrants have a tangent theta greater than 0 and a cotangent theta greater than 0. In other words, the values are going to be positive. So let's take a look at a coordinate plane, and let's draw up a angle in quadrant 1. Here, I'll have a point on a terminal side, and in this situation, my x will be positive, and my y will be positive. So when I substitute my values in for x and y, positive divided by positive, I'm going to get cotangent and tangent theta both greater than 0. So in this situation, quadrant 1 will be a solution for my problem. If we go to quadrant 3, I'll have a point on a terminal side on that angle, and that will give me an x value that is negative and a y value that is negative. In that situation, when I substitute in a negative divided by a negative in both situations is going to give me another positive value. So therefore, in quadrant 3, tangent theta and cotangent theta are both going to have values that are greater than 0. So the solutions to this problem are going to be 1 and 3. If I used quadrant 2 and 4, either my x or y values would be negative, and that would give us a tangent or cotangent theta that would be less than 0.